In this video, we're going to talk through Objective 2, find graph features of a quadratic function if given a picture of its graph. Alright, I'm going to do two examples, and then I'm going to have you pause the video and try two examples on your own. Check your work with mine before you go ahead and try the practice for this objective. So to begin, the first example, number 4, if I was given this picture of a graph, the first thing I would notice is that it looks like a U shape, an upside down U shape. So if you remember from the previous objective, a U shape represents a parabola, and a parabola is a quadratic function. So that I know quadratic meaning that it's going to be x to the power of 2. So this function is x squared, all right? And then the other thing I know from the picture is that the endpoints are going down, so that represents a frowny face or a negative function. So the a term of this function is negative. That's just for your information, but that is a very important thing to be able to deduct if you're given a picture of a graph, whether it's positive or negative based on the endpoints. All right, first graph feature that I want to talk about is the vertex. Again, the vertex is either the maximum mountaintop or minimum valley of the function of the parabola, and it's also where the two halves meet. So in this case, that exists right here. And that plotted point is 0, 4. X value is 0, so that should jump out at you as another graph feature we're going to talk about in a little bit. But that is the vertex, 0, 4. Domain, moving on, is the x value, so the lowest x value to the highest x value, so the horizontal left to right motion. In this case, the lowest x value and the highest x value have to do with the endpoints right here. All right, so the lowest or the leftmost x value, the most negative x value, is this endpoint right here. And the rightmost or highest x value, or most positive x value, is that endpoint. And so right here, this leftmost endpoint is going to go down forever, but it's also going to go left forever. And that number is negative infinity. And this end value is also going to go down forever, but it also goes right forever. And again, right forever is positive infinity. So it includes all real numbers, negative infinity, positive infinity. Another way I can write that is the symbol for all real numbers like that. Now the range is the y value, so it's the lowest y value or the floor to the highest y value, the ceiling. So the lowest y value is again dealing with these endpoints right there. Both endpoints go down forever, which means the lowest y value or the floor is negative infinity. Alright? The ceiling of this, or the highest y value that exists in this function, is up here. Alright, the y value in this case of the vertex is 1, 2, 3, 4. So the highest y value that exists in this function is 4. And it's a closed dot on that vertex, which means 4 is included in the range, so I have to bracket it, right? Not point the ceiling. And that is the range of the function. If you notice, for all quadratic functions, the domain is always going to be all real numbers unless otherwise noted, and the range will be something similar to what I just wrote there. Axis of symmetry is the x value of the vertex, or the value that cuts the parabola in half. So if you notice, it's going to be right there. So that is x equals 0. Again, cuts it in half. So it's always going to be the x value of the vertex. It's the axis of symmetry. X-intercepts, there's 2 of them. One right here and one right here, where they cross the x-axis. So the first one is negative 2, 0, and the other one is 2, 0. If you notice, the y values of the x-intercepts are 0. Moving right along the y-intercept, there's one of them, and it is up here. In this case, it is the same as the vertex. That can happen. It doesn't always happen, but it definitely can happen. So the y-intercept is 0, 4. In this case, the x value is 0, the y-intercept. And then we did talk about this at the beginning, but this function is negative meaning there will be a negative up front of the standard form of it because the endpoints are going down. All right, I'm going to do one more example before you try yours on your own. The vertex of this function is right here. So it would be -2, comma, 0. All right? The domain is all real numbers. The range is the lowest y value, which these endpoints go on forever. So it is -infinity to the highest y value, which in this case is the y value of the vertex, which is 0. The axis of symmetry is always the x value of the vertex. The x-intercepts, in this case, there's always two roots to a function. In this case, it's a double root because it only touches the x-axis once, which means that the only solution is at -2, 0, but -2 exists twice in this function. And we'll talk about that later as to why that happens. The y-intercept hits right here on the y-axis, and that plotted point is 0, comma, -4. And then in this case, this parabola, the endpoints are also going down, so it's negative just like my first example. Remember, if the endpoints are going up or it forms a smiley face, it's positive. All right, at this point, I'll ask you to pause the video so you can try these two on your own, and then unpause the video so you can check your work with mine. At this point, you should have paused the video to try these two problems on your own to check your understanding. Here are the answers that you should compare your answers to. Hopefully they line up exactly with what I put on the screen, although I do make mistakes, so if you don't have something that looks like mine, please raise your hand so we can talk about it. The biggest thing I want to talk through is on example 2. If you notice, this is the only positive function I gave you to try of the 4 that we've worked through. So the endpoints are going up, which means it is positive. And then again, the biggest thing that happens with that is it affects the range, all right? So if the function is negative, the range will always start at -infinity. The lowest point will always be that -infinity because the endpoints go down forever. If the function is positive, it'll always end, the range will always end, the highest y value will always be +infinity because they're going up forever. And the other thing to recognize with the range is it always includes, for quadratic functions, it always includes the y value of the vertex. It just is flipped. So again, if it's negative, the y value is written second. That's the highest point. That's the maximum. But if it's positive, the vertex is the minimum, and so the y value of the vertex comes first because that's the lowest y value that exists in the function. All right, again, if your answers don't match up with mine, please raise your hand so that I can come over and check your work. Thank you.